Hi everyone, in this video I want to talk about graphing quadratic functions in what we call standard form. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. If you could grow one fruit or vegetable regardless of climate, which would it be? So on the math section, quadratics are inevitable. It's possible that you could have to solve them, maybe graph them. Um, who knows? Maybe there'd be a system of equations with one. But let's think about the basics of graphing and the three different forms in which you could see the equation written. So standard form is what you see here in 1 and 2. You could also see the problem written in vertex form or intercept form, which is another word for factored form. So standard form here sometimes is the hardest one because there's a lot of digging you have to do first in order to figure out, some bits and pieces of the graph that are really important. So right away, the very first thing that you should try, and I'm going to take a little, take note of this. So checklist question that you ask yourself: is equation factorable? So let's try that. Let's try to factor out try to factor this first trinomial into two binomials. Okay. Right when I see that negative x squared, I think, oh, I should probably take a -1 out of everything so I don't have to even mess with the negative. So let's do x squared and then what? Minus 4x, but plus 3. Notice I'm just changing the sign of all of the pieces. Now it's a little bit more clear. I can factor this into, let's think, anything. So I'm trying to think of two numbers that multiply to 3 and add to -4. Oh, well, if I go x minus 1 and x minus 3, those two will add to a negative and multiply to a positive, and those are the correct numbers. So we did factor it. Now, if you see the video on factored form, all you would do here is to find the x-intercepts is, remember this is like y or f of x. You would just go y equals, I'll label this, x-intercepts. You would just do y equals -1, x minus 1, minus 3. I'm going to sub in a 0 for the y when I'm trying to find the x-intercepts. And we get -1, x minus 1, x minus 3. Now, to figure out what x would equal, if the whole thing equaled 0, then surely one of those three pieces would have to be 0. So I'm going to set the x minus 1 equal to 0, the x minus 3 equal to 0, and I get 1 and 3. Okay, so I have my intercepts 1 and 3. That's where it's going to hit the x-axis. Those are also called roots or zeros. X-intercepts, roots, and zeros are all the same thing. All right, now I don't know anything else about the graph. So what I have to find next is, once I have two intercepts, we're golden because we can find the axis of symmetry, which is, taking that 1 and 3 and averaging them. And that's going to be 4/2, which is 2. So my axis of symmetry is cutting those two intercepts in half. I know that's going to be the mirror line that's, the reflection line. This whole thing's going to be symmetric about that line. But what's really important is finding the vertex. The vertex, the point that lies in the middle of this graph, it's got to fall on that line. So we know that we can steal that 2 to be the x of the vertex. And so all I'm going to do to find the y then is just go y equals, and then just, plug in a 2 everywhere I see an x. I'm just plugging that into this equation here. So I'll get y equals, and then this is where I have to be kind of careful. negative, and then it's like 2 squared, so that's -4 plus 8 minus 3. And then I end up getting that is 1. Okay, so my y is going to be at 1. So 2 comma 1 is my vertex. And hey, that makes sense because I know that this graph is going to be turned downwards because it's negative. And so in our checklist, we say, is it factorable? Okay. If it is, we just do what we talked about in factored form, that video, if you'd like to watch it, which is what I just did here. But for number 2, I want you to think about, if something is not factorable, then what do you do? So just to do some quick math here, I can either do guess and check for factoring, or I could do split the middle. I kind of like split the middle right here because then I can go 2 times 33 is 66. Does anything multiply to 66 and add to 16? So I go, okay, 66 is 1 and 66, 2 and 33, 3 and 22, 6 and 11. Okay, do any of those add up to 16? They don't. So what we have to figure out is, if it's not factorable, so we'll say if not, so is equation factorable? Factor. If not, quadratic formula is the way to go. Okay, so quadratic formula, I've established this is not factorable. And so the quadratic formula is going to tell me, well, first of all, it's negative b plus or minus square root b squared minus 4ac over 2a. That's going to tell me where the x-intercepts are, because remember, you're solving for x for this. So we're going to do, remember, this is a, b, and c. This is negative 16 plus or minus square root 16 squared minus 4 to 33 all over 2 times 2 equals negative 16 plus or minus square root. And I do have a video on solving using quadratic formula if you'd like to see more details on that. What I'm doing is plugging this in the calculator, and I'm getting a negative 8 over 4. Okay. So I end up getting a negative 8, and what I have to figure out is, what do I do now? If I have an imaginary number as a part of my answer, then how do I incorporate that? Well, what we could do is at least just figure out how to, this is good practice. How could I simplify this? Square root of -1, square root of 8. That's how you could break down the negative 8. Put that all over 4. 16 plus or minus, and then that'd be 2i root 2 over 4. I could keep that going and say 4 plus or minus I root 2 over 2. And then I go, there is nowhere I can graph that on the real number line. It doesn't exist on the real number line because it's not a real number. So that tells you that there's going to be a graph that's sort of floating in air somewhere. This is the harder case. So what I need to do is basically, I need another trick up my sleeve that's going to tell me where the vertex is, and I can maybe figure out as a y-intercept as well. So you kind of think of, okay, if I can't do intercepts, like if not quadratic formula. And then another thing I want to say is, if imaginary, it's like, think of this as like easy, medium, hard. Sometimes quadratic formula just tells you where to plot it on the x-axis, right? But if imaginary, then we're going to use a trick that's just use the y-intercept and the negative b over 2a to find vertex. Okay, let me show you what that means. So vertex. It's the trick is like you can do negative b over 2a, comma, and then just whatever the y is. So this b number is negative, well, it'll be negative 16 if it's negative b, over 2 times 2, comma, whatever the y is. Let's simplify that. So this is going to be negative 4, comma, and then I can use that negative 4 to figure out what the y is. So let me copy that down. 2 times negative 4 squared plus 16 times negative 4 plus 33. Place where people mess up, by the way, is right here. Negative 4 squared. All right, so I'm using a calculator, and I'm getting 1 is my answer. Okay, so my vertex is negative 4, comma 1. Okay, now that's a big deal. This trick, this negative b over 2a trick, is the only way that you can find the vertex. It's like you need a different tool in your tool belt when you can't use that average the intercept sort of thing. And so I know negative 4, 1 is my vertex. I know this is going to be pointing up somewhere because this 2 is positive. So my next question is just where is it going to, how can I plot another point? Well, let's, keep organized. That was my work to figuring out the intercepts. Well, there aren't any. So vertex is over here. And then the last thing is you can also use a y-intercept. So y-intercept is setting the x is equal to 0, solving for y. We now get y equals, this will be 2 times 0 squared plus 16 times 0 plus 33, y equals 33. Oh, so this is way off the graph, and so it's going to be, imagine it like all the way up here, right? But just for the sake of a nice graph, let's just draw it like this. Okay, we know if you have one side, and let's call this 33 up here. The graph is going to be symmetric, so you know that whatever you have on one side, you'll have on the other, which is why you really only need a y-intercept as your last point, because then you can draw one side of the graph, then mirror image it over the, the axis of symmetry will cut through that vertex. So there you have it. We have sort of a small, medium, hard kind of situation here. For practice problems, here are 2. It's kind of hard to tell if they'll be, the easy, medium, or hard. Give them a whirl. You can pause the video and I'll reveal the answers. Okay, here they are. One's pointing upwards, one's pointing downwards. Notice this would be the hard one because it's floating. It does not hit the x-axis here. And that tells you that there are no x-intercepts. So think about, using the quadratic formula, and then how would you find the vertex there? So a quote to leave you with some inspiration here. Happiness is not something ready-made. It comes from your own actions. So I hope this video helped you in some way, and feel free to leave your answer to the fun question in the comments. And you can subscribe if you'd like to keep up with new videos. Thank you.